Hey guys, welcome back. There isn't really anything new today, but I just want to do a quick review of some of the things you might be confused about. Okay, so first, the difference between integrating 1 over u, or integrating u, or integrating 1 over u to any other power. Okay? The first one, this one's natural log. This one, the next one is a power rule. That's just u to the first. Don't let that screw you up. So that one's going to be u squared over 2. This one is also a power rule. Just move it up and make it u to the negative 2, and it's a power rule. Add 1 to the exponent, divide by the result, and then clean it up. Negative 1 over u. Okay, so don't confuse those. The only time it's natural log is if it's u to the first in the denominator. All right, the next thing I want to clarify is when is it inverse trig versus regular u sub? These two problems look almost identical, except the second one, the one in blue, has an extra x. So how do you know what to do? Remember, you should always consider the entire denominator as your u first. If I let this entire denominator be my u, then du would be an 18x, and I don't have an x up here, so that's not going to work. And that's why the first one here is actually inverse tan. So assuming that it is inverse tangent, I'm going to write down my a, my u, and my du. A is the number I'm squaring here, u is the function I'm squaring here, and du I figure out on my own. So I need a 3 and I have a 7. The 7 is in my way, so literally take that 7 and scooch it out front and get rid of it. That still has the same value because 7 times 1 is still 7. But I still need a 3. So I'm going to add the 3 and balance it out with a third. Okay, so now this part will bring down into the answer, and all of this is going to go to the formula. Remember, tangent gets a title. Tangent gets a title. 1 over a times inverse tangent of u over a. And then you're going to multiply that across and get 7/6. Okay, so that's an inverse trig problem. And that's about as hard as it could get. All right, now this one is regular u sub because let the entire denominator be your u, and du is 18x. I have the x that I need. Now the 7 still has to be moved out. It's still in the way, but I can add this 18. I can't add an x. So I'm going to move the 7 out. That did not change any value, so I don't have to balance it out. However, I still need this 18, and I'll have to balance that out with an 18th. So now when I rewrite this, the 7/18 is brought down. And this is the integral of, we have a u, all of this is a u, and all of this is du, but I prefer to put it out here. Okay? And so the integral of that ends up being natural log, totally different than the last problem. Natural log of u, and change u back into what it was. Okay? So on the worksheet you got today, there were 2 of them. One of them's all just u sub, pretty much. But the other one has a little bit of regular u sub mixed in with the inverse trig. Okay, so which problems on that more integration worksheet H, which problems end up being regular u sub like this one? If you look at that worksheet right now, I want you to go through and find the ones that are regular u sub. And the hint is typically, but not always, that extra x in the numerator. So the ones with regular u sub should have been number 2. Let's see, what else? Number 4. And number 7, because it's not a 4x squared in the denominator. Okay? So if you have any questions on how to work any of those out, let me know. Number 10 is optional because it's inverse secant. I'm not going to actually ask you that. All right, don't forget, keep asking your question, guys. Thank you. Bye.